This is the IBM ProPrinter. It's designed for assembly. We'll start off by pointing out a few of the key design features, and then during the assembly you'll see the significance of those features. The base is a large fiber-reinforced molded plastic part. It acts as a pallet to carry the printer through the assembly. It also locates the two carriage side frames with respect to one another to minimize the tolerance demands. The left side of the carriage locates the two drive motors and the drive gears, and the designers took advantage of the elasticity of the plastic to mold a little leaf spring in to position a shaft. This eliminates the use of linkages and pins and springs that would be necessary in a traditional design. There are a number of steel shafts that are used to guide the print head and the paper. Each of the shafts is located only on one end. The other end is allowed to float. This minimizes any tolerance demands during manufacture. Also, all the locating diameters are different so that the shafts cannot be snapped into the wrong place. The print head is driven by a molded plastic screw pressed onto the end of the drive motor. The screw eliminates the use of belts and pulleys in a traditional design. All of the power and control circuitry is located on a single PC board. This eliminates the use of multiple PC boards and the interboard wiring operations that would be necessary during assembly. Also, sensors are used to indicate when paper is present and when the carriage head is returned. This eliminates the use of a micro switch and, again, wiring operations. Power supply consists of a transformer, an on-off switch, and a power cord outlet pre-assembled into a functional subassembly which can be tested before final assembly. There are a few points to note during the assembly operations. First of all, the goal of straight-down insertion has not been achieved, even though this is the state of the art in design. However, the motions that are required are simple and do not require much dexterity, so they can and have been automated by IBM. Secondly, the base will not be reoriented during the assembly. All of the required operations can be done from a single position. Finally, you'll note that no tools or screws are used during the assembly. We'll start off by putting the PC board in position. The power supply is then snapped in over it, capturing it in place, and plugged into the PC board. Paper tray with a locating guide is then snapped in place. Carriage frame takes two drive gears for the paper drive assembly, and the drive motor slips in place and twists to lock. It's then snapped to the base, and the motor is plugged in. Drive roller assembly slides into the carriage frame, is captured by the other side. Cast aluminum platen then snaps in place between the two side frames, fixing the width. Another paper tray is then slipped in and snapped to the base, and a tensioning shaft is snapped into the two leaf springs mentioned earlier. The drive screw and motor slide in, and the motor twists to lock, similar to the other motor. Okay. The print head slips onto an eccentric shaft to adjust the contact pressure between the head and the paper. It's aligned with the nut and snapped in place. The print head is then plugged into the PC board. A small clip is snapped onto the end of the shaft in case the adjusting arm should ever come off. The tail shaft is used to support the back end of the print head. Drive gears are snapped in place to drive the ribbon. One is equipped with a spring clutch which replaces a whole reversing gear assembly in a conventional design. The tractor drive assembly is then built next. Main drive shaft snaps in place, and a roller is snapped over the top and twisted to lock in place on a shaft. It's very difficult to slip a roller onto the end of a shaft, and this operation is very simple. Molded plastic parts are then snapped in place to fix the width of the paper. Comparable parts on another printer have springs as part of the assembly. A keypad is then snapped in place, making both mechanical and electrical connections simultaneously. The ribbon is then snapped in place. This is typically a fairly difficult operation since the ribbon is flexible. IBM allows the customer to take care of this. At this point, the printer is functionally complete and can be inspected, and any adjustments that are necessary can be made. After that, the hoods are snapped in place. Paper drive knob. A cover and a form separator are slipped in place. And the printer is complete. We'll plug the printer in. Okay. We have a working printer.